So, I'm Nicolai, and not Metallica, unfortunately. And I'll be talking about JUnit 5. So, by a show of hands, who uses JUnit? Wow, great. No, keep it up. Who used JUnit like last month? Last week? Wow, today? Nobody. Well. Okay, cool. So you guys have to help me when we go through the first slides. Before we do that, a small heads up. JUnit is work in progress, and there's a team working on that right now. It's open source, of course, and I'm not a member of that team, just to get that straight. What I'm going to talk about today is based on the alpha version. It was released in February, and development has gone on since then, and there's a milestone 1 planned for beginning of June, which we passed, but now it's going to come out, I guess, any day now. And if you see something that you really like or really dislike, then you now have the chance to give feedback, well, to me personally, but especially to the team, so they can incorporate your wishes and use cases. So in case you want to do that, there are some links that you should totally click on later. But let's begin. Let's start with the basics. Some stuff is new in JUnit 5 on the basic level, and I want you to tell me what it is. So I'm going to show you valid JUnit 5 code. This works, and it's somewhat different from JUnit 4. And who can tell me what that might be? What's the difference here? Right, no public. Great, right? So that useless modifier is gone. What's new here? Exactly, it's called before each and before all. So the lifecycle methods have new names, but otherwise they're exactly the same. What's new here? Disabled. It used to be ignored. That's not a big change. What's new here? Well, I give you a hint. This is not part of the official API. So we could do our own stuff. And it's really convenient too. How? We'll see that later. What's new here? Yeah, the message is in the back, exactly. I like it. It always bugged me that the message was in the first place, and sometimes I have one, sometimes I don't. So message comes last. And this is obvious, right? Hey, we can use lambdas. So if you have very expensive message, you don't have to create it every time. You can just, delay that until you really need it. What's new here? I wish I could come down to understand you better, but I don't have a clicker, so I can't advance the slides at the same time. So what's new here? Assert all. So what could it possibly do? Exactly. It runs all of the assertions. This is really great. Sometimes you have a couple of things you want to check, and as soon as the first one fails, you never find out what the other ones are. Now you do. This is how the message would look. So it tests all of these things, and all of them have been wrong. But you get a whole output for everything. So here's our method under test, and it seems to throw an exception. And what can I do now? There's an assertion to check which exception is thrown. And actually, in JUnit 4, there used to be the parameter that you can give to the annotation that says, I'm expecting this exception. And that's gone on purpose. So to keep it simpler and to make it more explicit, which operation exactly is supposed to throw that exception. Okay, I'll pick the next one, because it's basically like the last, but you can get the exception back and do some more stuff with it and check whether it has the right message, for example. And so you can examine it more. This is cool. What's new? nested. What might it do? Yeah, exactly. It just runs the test in there. This is pretty convenient if you want to organize your tests in inner classes. You could do that before. There was a runner actually that could do that, but this is much simpler now. And then we have display name. That's so obvious. I'm going to do it as well. You can get great names to your tests. And this works really well together. So if I use nested and display name, and then I use IntelliJ to run the tests, this is what I get. I hope everybody can read it. So what you get is basically a very BDD-style description of what's going on. I can read that a stack, when new, after pushing an element, is no longer empty. And I think that's pretty descriptive. What's new here? Parameters, exactly. So somehow I can pass in a parameter. Where does it come from, though? I mean, JUnit doesn't know about my server. We'll see that later, too. So we're done with the guessing game. This is the superficial part, the API that we're going to use every day. And some of those things changed. Lifecycle works much like before, but many of the details were improved a little bit. The names were a little bit better. We can somehow inject parameters. We didn't look at how that worked, though. And we haven't seen lambdas so much. So it used to be called JUnit lambda. So where are the lambdas? See that now. And I also said the title is called, of the talk, the next generation testing. This is lame, right? I mean, it's a nice improvement, but how is this next generation? Okay, let's talk about dynamic tests. Up to now, if you wanted to define tests, you used to do it in JUnit 3 by having a method that said test something. And in JUnit 4 and also 5, you have annotations. But they have something in common, something critical. These tests have to be declared at compile time. You cannot at runtime decide, ooh, I found some new things. I want to do some more tests. And you might want to do that at some point. So if you want to use lambdas, we are creating tests at runtime. If you want to create tests for a huge amount of parameters, we have to create them at runtime. I mean, the parameterized tests in JUnit 4 is always something painful with theories, and there are other plugins that you could use, or libraries that you could use, but none of them really work well, and the reason is that JUnit 4 has no concept of creating tests at runtime. What if you want to use non-source files? Maybe your other departments in your company are creating test data. Maybe you just want to run them. How could we do that? And we have to do that. We have to be able to define tests at runtime. And this is where dynamic tests come in. You can do exactly that. You can create tests at runtime. So you wrap your tests in an instance of what's called a dynamic test, and then you annotate some method that returns a bunch of those tests with test factory. And then it just works. We'll see how. But this is not part of the alpha version. So if you check the alpha version out like right now, you won't find it in there, just as a disclaimer. So this is how it works. We have our method, create point tests. So we have this point class, we want to test it. We have create point tests, and it's annotated with test factory. So JUnit knows that it's going to look for dynamically created tests in there. And then we just return a list, or it could be a stream, or any collection, or iterable really, with our tests in it in that collection. And what we then call is dynamic test, which is a static factory method on the class of the same name. And we just give it a name and the test code. And the code that it's supposed to run is an executable, which is much like a runnable, but it can throw anything. So we can then put our code into test code. And what then happens is pretty straightforward, right? So JUnit looks for these annotated methods, finds some test factory annotated ones, and calls them, generates the tests, adds the test to the test tree that it's building, and at some point later it will run them. So when from the perspective of the IDE or the tool, these are just normal tests, just like the other ones. Okay, so what about all this Lambda tests things that I've been talking about? I think what we would, I don't know whether all of us, or me personally even, but what is the general idea here would be that we somehow can write tests like this. We can just say, screw all the ceremony, we don't want that, we don't need that. We just write the names test, and then the Lambda arrow, and then we just write the test code. That would be so awesome. But as you can see, this is not even valid Java syntax. You have to assign a Lambda expression to something, and this is not here, so this doesn't compile at all, but we want to get close. How could we do that? With the dynamic test that we just saw. So let's sink in for a moment. So what we're doing here is we're declaring a list of tests, and then later at the bottom, JUnit will come by this class and see, oh, there's a test factory method. I'll call it. And we'll just return the test that we registered earlier. So how do we register tests? We have this method, and we don't want to even see the method. So I gave it 2 underscores as a name. I would have preferred 1, but that's from Java 9 on, you can't do that anymore, which probably you shouldn't have done in the first place. But so it could be any name really, but I gave it 2 underscores so we don't see it that much. And then we just give it a name and the executable, and it will create that test. It will build it itself. And then, when we really want to do this Lambda thing, we do our point test, we extend from Lambda test, and then what's happening? The double curly braces. That's called double brace initialization. And what it basically does, it creates an anonymous class and executes the codes that in there in its constructor. It's really hacky, and it's generally not a good advice to do that. Maybe here we can get away with it. So now we call our double underscore method, and we give it the great name for the test, and then just a Lambda expression with the test. That's, I don't know, a little bit closer to what we wanted. While we are hacking, we can get even closer if we really, really want to. Because there's this one weird trick with which you can determine the name of a Lambda parameter. This is really weird. You could look at it later maybe in detail if you want to. So what's basically happening here, we're having this parameter, a great test for point, which is a string parameter, but we don't even use it in the test. We use it by reflection to find out what it is, what the name is, so we could use that as the test's name. Again, this is really weird, and I'm not sure whether it's worth the effort. But if you really want Lambda-based tests, this is how we might get them. Okay, let's go do something more concrete, something that we actually do need, or at least I need on a daily basis. I often want to have the same test executed on a bunch of test data. The simplest way to do that is just to write the loop yourself, right? You just say, I create a bunch of points and put them into my point test in a loop. But the downside with that is that for JUnit, it's one test. So if of those 20 points, the 30th fails, then the whole test will fail, and I wouldn't see immediately which one it was, and somehow it doesn't work that well with the tooling together. So you have to, it would be ideal to have an individual test for each of those. And you can do that with JUnit 4, but then you often have the case that you have to run all the tests in your class on the fields that you're parameterizing, which is also not that nice. And this we can do on a more local basis. So let's say we have our class point test, which surrounds all of this, and we have this one method that tests a single point. What we could do now is we just create a stream of points, and then we take each point and create a dynamic test for that point, and then give that to JUnit. And then JUnit will see, oh, you have 20 points, but you made 20 tests out of that. And so, as I said before, in this test tree for the tools, for whatever you're using, this will show up as 20 tests. And then you're in line with how it should work. You can get very individual messages to what actually went wrong if something goes wrong. There's a different syntax to do that as well, but it's basically the same. You just use a different method on dynamic test to stream those points, and for each point create the test with a name and the method. And if you really want to, you could use other things. Maybe you have a file where you dump a bunch of points that are interesting for whatever reason, and you want to use that. So in that case, it's also pretty much the same. You can just stream the lines from the file. So path to point file is an instance of class path. You can just stream all the lines, parse points, and then map them to dynamic tests, and again have JUnit take care of the rest. That's pretty cool, I think. So you can do, with test vector and dynamic tests, you can easily create tests at runtime. We can do that the libraries that we might be using can do that. And it allows us a couple of things that are way easier than they used to with JUnit 4. So we can use lambdas if we really want to. And as I showed before, we can use sets of parameters, and we can even base it on external input if that's a good reason for that. And again, that's all very nice. But this is not like next generation. This is just some incremental improvement. But we'll get there, don't worry. So let's look at extensions. Because as usual, the tools will not do everything we want right out of the box. And there's always the question of how they can be improved and how open source developers or general developers within companies can improve the tools they're using. And with JUnit 4, this was somewhat complicated. Out of the box, JUnit 4 had this concept of runners. So if you wanted to do something new, do something different, like the Mockito JUnit runner, then you had to create a runner that had to manage the whole test lifecycle. It had to do, you could inherit and get a lot of that functionality, but basically you were in charge of managing the whole lifecycle of all of the tests in that class. And this, of course, made it very flexible. You could basically do whatever you wanted. There's nothing that, well, there's few things that you couldn't do that way. But it's also pretty heavyweight. If you want to do just a small thing, and you had to use runners because there were no alternative back then you had still do all of the ceremony and experiment everything else. And then you had the problem that it was exclusive. So you couldn't mix your runner with the Mockito runner. You had to pick one. And that was actually a big problem. So in 4.7, they added rules, another mechanism to extend JUnit 4, and it basically did some stuff before and after executing a statement. So that's very rough and not precisely true, but that's the general idea of it. And that was really lightweight. You get many things that you had as runners before, you can now get as rules, like the Mockito JUnit rule and Spring does stuff, and that was pretty nice. But it was also limited to certain kinds of behaviors. It was not that general as the runner. And to make things worse, now you have two mechanisms. You have the rules and the runners, and so maybe not all of the extensions that you want to use are implemented in both, and each mechanism had its own limitations, but also very much overlap. So if you want to do something yourself, it was not that easy to find out which way might be the best. So somehow this was not ideal. It worked well, but it was not ideal. And composition could cause unforeseen problems where things did not cooperate the way they were supposed to. So when JUnit 5 set out, they decided on some core principles, and one of those was to prefer extension points over features. So whenever possible, the question was, do we have to implement this ourselves as a feature, or can we provide an extension point, and then maybe, if it's really important, already provide an extension that does this, but without being privileged, without having some special status within the JUnit 5 code base. So the JUnit 5 team repeatedly creates features as an extension to their own work. And quite literally, the expansion points did actually make it into a feature. And these are, well, in the alpha version, these are all of them. Maybe there are coming new ones. And it's not that important to look at all of them and memorize them, but you can see that there's a lot of stuff there. Parameter resolution, the lifecycle methods are in there, something with conditional tests. So you have a lot of extension points for various things throughout the creation and running of tests. So, okay, we have extension points. What exactly does that mean? If you want to create an extension, what exactly does that mean for us? And it's really easy, actually. There's one interface for each extension point, and there are a couple of methods for each, and JUnit gets everything there is about the test, all the context that it can find, the test method's name, the class name, the parameters, the annotations, whatever it finds, it hands to our extension, and then we can do stuff. And if we want to create an extension that does something non-trivial, we might want to implement more than one of those interfaces to use more of these extension points within the same extension. So this is the example of before each extension point. It has a before each method, and as I said, JUnit gets everything that it finds, puts it into a test extension context, and gives it to our code. And then we can do, well, pretty much everything. So let's make an example. Let's try to find out how can we extend JUnit 5. Let's say we want to benchmark our tests. And for each test method, we just write the time to the console. That's very easy. And if we sit down and think about how we might want to do that, then the words before each and after each crop up immediately. So we want to store the launch time before the test, and then we want to compute the elapsed time after the test and print it. Seems straightforward. So we have this benchmark extension. It implements both of these extension points, before each and after each. And we have this field where we store the launch time. Oh, what? Oh, sorry. Here we go. So before each test, we just call system current time millis and store it to the launch time, and we're done. And after each test, we do our computation. We again take the current time and subtract the launch time, so we get the actual runtime. And in this case, we just print it to the terminal. So that was pretty easy, right? So remember this? So how would that work? And now we know a little bit more than before, and it turns out it's not that hard at all. So there's an extension point for test execution, and we just implement that point, and when the evaluate method calls us and asks us, look, this is everything I found about the test method, do you want to run it now or not? We just check whether it's Friday, and if it is, we disable the test. And this disabled method is a static factory method on condition evaluation result. So we just call that, and otherwise, every other day of the week, we enable the test, and tell our developers to fix it. And we had one last thing on the first slides that were not immediately obvious how to do that. We wanted to get this my server in there. Again, there's an extension point for that, method parameter resolver. And it takes some more arguments, the methods, but I shortened the list here. The important part for us here is that we get something that captures the parameter. And we can ask which type is the parameter. And then we look, is it even the class that I'm supposed to work on? So I'm just writing this extension for the my server, right? So I want to make sure that I only am asked to produce my servers. So that's easy. In the support method, I'll just make sure that I'm getting a parameter of that I'm supposed to create a parameter of that type. And when I'm then asked to resolve the parameter, I just create a new server. And in all of the things that JUnit gives us in these extension points, there's, as I said, there's also annotations and everything else in there. So you can use other mechanisms to transport more information to this point. For example, if the server needs an URL, you could give this, you can create your own annotation that would take this URL and you could use it here. So you can actually get information from the test context. Okay, so we created all of our extensions. That's cool. What we do now? Because somehow JUnit has to know that these extensions exist. Otherwise, how can it use them? And there's a notation. It's called extend with. So it would maybe be like the notation for runners in JUnit 4. And you can put it on tests, individual test methods, or on the test classes. And you can say, look, JUnit, I wrote this cool extension. Use it to run the tests in this class. Doesn't look too good though, right? I mean, that is very technical and, I don't know, doesn't read natural. So we can use a trick. And this is my experiment at trying to how often can I put the word annotation on the same slide. So all annotations in JUnit 5 are meta annotations, meaning you can annotate other annotations with this Java's hamstrung way of doing something like inheriting annotations. So everything, all the annotations that JUnit defines, you can use them on other annotations. And JUnit knows this and looks for that. So whenever it finds an annotation, it recursively checks everything that's on there to gather all the annotations that might apply. And that means we can create our own annotations easily, because we can create an annotation, put it in our class or test, and when JUnit sees it, it will go up that tree and look for annotations on it and do so until it finds everything, and then we'll check, is this, for example, a test? And if yes, I will run it. So here we created 2 annotations and used it right away. So the first thing we did, created our disabled on Friday annotation. And we used the annotation and immediately tell JUnit which extension is in charge of this annotation. So we put both information together. This is disabled on a Friday, and also, by the way, JUnit, if you're looking for the extension that implements this, it's also annotated right there. And then maybe we have integration tests that we want to run differently. Now we can tag them, something we're not looking at today, so you can filter tests by that, by tagging. And because the integration tests, they always take a long time, we're interested in how long that time exactly is. So we're putting on our benchmark extension, and we're integrating with the things we're testing is our my server. So we want to do that as well. We want to put on our my server parameter resolver and bundle all of that up into one small annotation. So we don't have to repeat this bunch of stuff everywhere. And so then if you want to test the login on my server, we just do both. We just say, okay, this is an integration test and don't bother me on Friday. So as I said, when JUnit finds this method, it goes up the path to all the different annotations it finds, and we'll see eventually the test annotation there and know, oh, this is a test I'm supposed to run. It will see that there's the benchmark extension and the parameter resolver, and it will call those extensions and use them as we planned it will happen. Okay, that's nice, I think. So now we have a very clean extension model. It can't do anything yet. It can't do everything yet. So for example, one thing that might turn up is you might want to make sure that your test runs in the swing thread. That, for example, is an example that cropped up that doesn't work right now at the moment. So it's not clear whether they will find a solution for that. I guess they will, because it's not that unimportant that you want to test your UI. You have to make sure that runs on the JavaFX application thread or the swing EDT. So I guess there will be a solution for that, but doesn't work right now. But otherwise, it's pretty flexible. You can do a lot of different things from a lot of different perspectives. One of the team members is also very strongly related to the Spring team, so he already implemented a bunch of Spring extensions. So that is a pretty big use case, and that is already covered. So it looks like this will support a lot of the things that we need to do with extensions. They compose pretty well, and since you can do meta annotations, it's really easy to use them in a nice way that makes it very expressive and write down proper names and give your users a good experience. And just to make sure, if somebody knows the alpha version a little better, then some of the things I just showed you are not entirely true. We had to leave out some details. You can check them out if you want to. And again, that's really nice. Is it next generation testing for everybody, or is it just nice for a couple of people using JUnit? And we will answer this question now when we talk about this architecture. So we kind of making like a deep dive. We started at the surface with the basics, what changes, and then we saw how dynamic tests give us more possibilities to create tests at runtime, and how we can use extensions to modify JUnit 5. This was basically from the point of view of a user. So let's change the perspective now and let's look at how JUnit 5 is actually built, how it's put together. So the JUnit 4 architecture, if you want to look at it on a module level like jars, and you want to be really mean, you can say there wasn't really an architecture. It was just a single jar, ignoring Hemcrest for the moment. It was just one jar, and everybody used it. You want to write code against JUnit 4, you had to use the jar. You want to write extensions, the same jar. You had an IDE or a build tool and wanted to do fancy stuff, you use the same jar, the same code. And these are all different concerns, obviously. It's a totally different concern whether I want to write a test or an extension or a Maven integration. And JUnit 4 did all of those things in one artifact, so everybody had to use it. And this made things a little complicated. So all the tools that we're usually using, they provide us with a lot of interesting stuff and a lot of awesome features that we as Java developers are happy to enjoy. But JUnit 4's API was not powerful enough for all of that. So what do we do? If the API doesn't work, what's the best way to get around that? I know, I'll use reflection. So I'm developing this tool, and I need something that JUnit can do, but doesn't expose. I'll use reflection. And that is what a lot of tools did. And it's not fair to blame those developers, because we wanted these features, and there was no really good way to do it, so they did the only way they had. But that meant that nothing was really safe. So there were private methods, even private fields, that these tools would access to find out what the current state is and make JUnit more transparent to us as users of those tools. But that meant that these tools are then bound to implementation details. So if you update JUnit, then some of those things might break. And this made maintenance really hard. Imagine working on a project where you're changing private fields, and then, I don't know, after the version is released, you get bug tickets and like saying, no, this isn't working. You broke my code, you broke my extension, or you broke my tool. That would really make maintenance hard. So the JUnit team had trouble evolving JUnit 4 any further. This was actually one of the major reasons why JUnit 5 started from the ground up, and why it's not just, the same code in the next iteration, because the iterations got really, really problematic. I mean, I think 4.12 is how long is it out there? I mean, technically there's a 4.13 coming, but I think it's in work for years. So JUnit 4 proved to be some kind of a dead end. And Johannes Link, who initiated the JUnit 5, or was one of the initiators of the JUnit 5 team, and the idea to re-implement it, said this, which I think summarizes it perfectly. So the success of JUnit as a platform, that everybody could agree on how to use tests in IDEs and in tools, prevented the development of the JUnit as a tool for testing. So there is two perspectives, like a platform for writing tests and running them in tools and IDEs, and the other end, you just want to write those tests. And so in JUnit 5, they took a different approach. Said, okay, let's split this up. Let's say we have an API to write tests against, and on the other end, we have a mechanism to discover and run tests. I mean, that makes sense, right? To split these two things up. But as soon as you do that, you might wonder, if we have a mechanism to discover and run tests, which kind of tests should it run? I mean, JUnit 5 tests, obviously, that makes sense, right? But why not maybe other tests as well? Couldn't this also run JUnit 4 tests? Or, I don't know, testng or whatever you could think of? So they split it up further. Still, point one is like it was before, the API for us to write tests against. And then there was the mechanism to discover and run tests, but it was split up. There's one mechanism for each kind of test, JUnit 4, JUnit 5, and other you could imagine. And then you have some kind of orchestration that sees which kind of tests could be run and does that. And then, of course, there's a fixed API between that. So this is how it ends up. So at the top are the tests that you're going to write. Yeah, it's readable, okay. And you're going to use the JUnit 5 API, which is a really small artifact. It basically consists of a bunch of interfaces and annotations. And on the other end, we have the tools. And before that, everything in the middle was just one JUnit 4 blob. Now it's split out. The tools are going to use the JUnit launcher. Hope you can read that. I mean, it's a little bit dark maybe. They're going to use the JUnit launcher. And the launcher does nothing much, but it knows that there are these engines, these things that run individual kind of tests. And it just goes to all the engines and says, look, somebody told me to launch tests. Please find them and run them. And then the JUnit 5 engine is one implementation of these engines. And JUnit 5 engine knows the JUnit 5 API. It knows which classes, how to look at classes and how to find out whether they're annotated and how to create tests and everything else that we talked about so far. So all we saw up to now was basically in those green bubbles. And now this shows how JUnit is going to run the JUnit 5 tests. And this is just what I've said basically. The API artifact is for us to write tests against. There's an engine API, so all the engines that somebody is going to implement are going to implement that. We have one specific implementation for JUnit 5. And then we have the launcher, which is the front end, so to speak, for all the tools. So that's great, right? We have a clear separation of concerns. We have an API for us, an API for the tools. And cool, but how is this next generation testing? And we're pretty close to the end of the slide, so I better come up with an answer now, right? And I think this is actually the crucial point, because it opens up the platform. Let's think about that for a moment. So say you want to run JUnit 4 tests. Great, now you can just write an engine within this architecture and have JUnit run it. Maybe you want to say testng, I don't like the tool support that much. I just do the same thing. Or Cucumber, or whatever you can think of, you can put it in its own engine. I mean, you want to write tests in a natural-like language, like you do in some other JVM languages? Sure, just create an engine for it that parses it and creates tests from it. So it can look like this. And just to be perfectly clear, the thing on the top right, the testng part, I made that up. It's not there, it's just my poster boy. But now the tools don't care which engines are there. The tools just go to the launcher and say, run tests, like maybe in this directory, or these couple of files. It could be more detailed, but the basic idea is the same. The tools just say, we need tests to run. And then the launcher has a lot of engines registered at it. So different engines said, hey, I'm the JUnit 5 engine, I implement this API. You know, if you need someone to run tests, call me. And the JUnit 4 engine does the same, and the hypothetical testng engine does the same. And then when the launcher gets called, it gets to all these engines and gives them the path and says, look, this is what I was told to launch, like find your tests in there. And then they will find their own tests, JUnit 5 their own test, and JUnit 4 their own tests, and then we'll run just that. And as I said, testng, that's hypothetical, but JUnit 4 is already there. So the JUnit 4.12 jar is in there, and I mean, it's in the graph, it's not in the JUnit 5 release, but the JUnit 4 engine is like a small adapter between those two. So you have it takes the JUnit 4 functionality and adapts it and implements the JUnit engine API. So already now you can run with JUnit 5 both tests, the old and the new tests, within the same code base. So this, I think, is the great thing, the open platform. This is the idea why I think this could be this is more important than just the next release of an API, of a library that we all use all day long, because now the tools can get decoupled from implementation details. Hopefully entirely, maybe not. I was told by the great guys at JetBrains that it's not clear whether the API suffices to do all the little tricks that IntelliJ, for example, does. But I wouldn't say that these details they could be ironed out, but the general idea is there. Once JUnit 5 or this JUnit launcher idea is adopted by tools like Maven or Gradle or the IDEs, then all the different testing frameworks that you can imagine just have to implement an engine and can get almost the same kind of level of support. And that means for us developers, they can try out new stuff. Before, it's like you can use this new testing framework and then you use it and then you realize the integration is just not that good. It's just not as detailed and as flexible and just can't use it fluently enough. And that is a shame, actually, that we can't try new ideas that well because they don't integrate with our build pipeline or our daily, or the IDE we use daily. But if this becomes reality and all these tools support JUnit 5, then we're in a different situation. Then we can just try new things out of the box as long as they implemented such an engine. And they can get like 95% of the tool support out of the box, and we can like have a very good experience using this new stuff. And this might also mean that it's much easier to produce new ideas, to create new testing frameworks that people can try out. And I think from this, really a new generation of test frameworks might arise where we just try out new things much more easily than we do now. So this means that JUnit's success as a platform that it had earlier now becomes available to everybody. It is decoupled from JUnit as a tool, which makes JUnit 5's evolution much easier, but it also means that the platform can be used by all other tools that want to. And this, I think, might really herald a new generation of testing on the JVM. So to summarize what we said about the architecture, with a clear separation of concerns, this might open up the platform and give tool support to everybody. And yes, again, I left some things out, and you can check them out if you want to. Okay, maybe I convinced you to use this. So maybe you think like, well, it's not that bad. The guy on stage rambled a lot, but maybe I give it a try. So how do you do that? How far along this everybody supports JUnit 5 are we? If you want to write tests, it's really easy. You can just add this artifact to your build tool of choice, and you can go ahead. And maybe very soon you can put milestone 1 instead of alpha there and get like the newest, best things. And then you can just write your tests. But maybe at some point you want to run them. And that is not that easy, unfortunately. So Maven has an issue for that, but nothing much happens. Gradle doesn't even have an issue, at least not one that I found. IntelliJ made good progress, and I heard that there may be an EA soon. And Eclipse also has issues, but they didn't advance too much. I think it's up to us to go to the tool of our choice and say, listen, I heard about JUnit 5, I gave it a try, it sounds great, why don't you implement it soon? And give it a little push and maybe even the commit here or there. But you want to run it now, right? You want to write tests and you want to see what happens. And I showed you a screenshot of what it looks in IntelliJ, so it must be possible. And yes, it is. You can, and that's a little crazy, you can run JUnit 5 as part of JUnit 4, which is strange because earlier I said that you can also do the other way around. So now what you're doing, you're relying on your tool's support of JUnit 4 and say, look, please run it with this JUnit 5 runner that I have here, and then you can just write regular JUnit 5 tests in there. Word of warning, it has to be public, at least the class, because if your tool is going to run those tests, it has to find those test class, and it won't usually, it won't if it's not public. And doing that on every class actually, well, sucks. So why not do it together with a package annotation? And that's actually what enables you to write tests right away. You just say packages, my company, I don't know, whatever, my product. Put that test class, this test suite class, somewhere in your test tree, and you're done. Like JUnit 5 will be called JUnit 4 will find the class, will tell JUnit 5 to run all tests in those packages, and JUnit 5 will run just the JUnit 5 tests. So already now, you can basically just start. If you want to, you can do it on your private project or in production even, well, not production, in test at work, I mean. You can start right away writing JUnit 5 tests, and you don't even have to tell anyone. So what about those build tools? They will pick up on the same thing that I just said. So the build tools will also run these tests. But JUnit 5 also already has some rudimentary support for Gradle and Maven with some plugins and providers. And they work reasonably well. And you can check them out. And all of this build tool, IDE stuff is not your choice. And you want to be like, oh, you want to be a guy who uses a terminal. There's also a console runner. And it's pretty obvious what it does. You say JUnit console, and then you give it a path to compile test classes, and then you go with -a to run all the tests, or with one specific test, and runs them from the console. Already has pretty nice output. And so if you don't want to do any fancy setup, this is an easy way to do it. So you can really start writing tests like right away. Tools have no native support that, but taking the detour via JUnit 4, you're pretty much there, and you can just start using it right away. Okay, second to last slide. We saw how the new API gives some incremental improvements, and I think it's a lot of thoughtful details in there that like give us some. They seem small, but I think they will actually be a considerable improvement of our daily development experience. Then we have dynamic tests, which can prove to be very useful to ourselves, but also to extensions that will use them to, or can use them to facilitate certain ways of testing things that are not fixed at at compile time. I think the extension model looks promising, and as we said, the architecture opens up the platform and might give us way more tools to play with and to improve our testing skills. And talking about tools, support is not there yet, but it will soon, I'm sure. Okay, word about me. As I said, I'm Nicolai. You can find me at codefx.org, where I blog. And usually I take questions. I know that in this room it doesn't work that well, so let's do it differently. I'll just end the talk now, and if you have questions, you just come up and ask me. Okay, thank you for being here on Friday morning, so early.